Welcome back to School of Civil Engineering. This is Adadullah with another new video. In our previous video, I have shown you that how we'll design a retaining wall. Cantilever retaining wall. So in this video, I'll show you about another retaining wall design. So in our past several videos, I have discussed about different types of machinery, concrete design, then quick foundation design, then concrete wall design, and also in this channel there have AutoCAD tutorial video, and also how to buy AutoCAD software, how you can get the free AutoCAD software. There have almost every requirement for a civil engineer for technical side, and also I focus on basic civil engineering knowledge, so that everything are available in this channel, and also given in uh, all playlists are given in description. So if you're new to our channel, you can watch that, and if you're a civil engineer, then don't forget to subscribe to our channel. So let's start. First of all, I will wait. Uh, I will open quick retaining wall, R wall, quick retaining wall software. Then here, so from here in our previous video I have shown you about cantilever wall design. So now I will show you about restrained wall. So here, restrained wall mean there have a cable to protect that wall. To reduce its overturning. So let's start and click here. After that, click OK. Now here is the wall. Okay, so here is our wall, and so as previous, it's almost same as our previous video. So I'll directly go to our criteria, then I'll go here, uh, IBC, okay, international building code. Now as a building code, then concrete load combo. From here, okay, select that. Then machinery load combo, you can select any one. After that, stability load combo. So from here, select that. And here, in previous video it's almost same. So if you think that if you need to know about that, you can watch our previous video. That playlist are given in description. So it's all are okay. After that, we'll go here loading. So for loading, it's also same as our previous video. So if we see in loading, what is the backfill depth? Suppose if we consider our backfill depth is 7 feet. Just this is our backfill depth, and everything, the terms, everything I have discussed in our previous video. That's why I'm going fast now. After that, here, lower grade, measured from lower grade or anywhere. Then slope, what will be the slope? You can give here the backfill slope. What is its slope? If you can give it, then you need it here, that gamma. Then here, frictional angle. Okay, so after that, water in backfill, if they have water in that side, you can also add it here like that. And you can also uh, give its height. Unit weight, and unit weight of water is 62.4 pound per square feet. And also you can change its your unit from here. And here, you can add load case, and here you can delete any load case. This is load case of 1. So after that, I will not consider water backfill. Then here is the passive pressure. Okay, so from here, analysis step, at which condition you want to analyze Rakhine combined at rest. So I will select the Rakhine pressure. After that, frictional angle phi. Here, frictional angle phi 30 degree. Then 30 degree you can change it according to your soil properties. So cohesion, if you have cohesion, you can give it here. Then unit weight, give here. After that, here, mm, here, soil depth to ignore. So apply to key. If you want to apply key, then you can select it, otherwise leave it. And after the searchers, if you have any searchers, suppose you have searchers, then you can select it here. Here searchers will be added, and you have to give the value of searchers, but I will not consider any searchers. After that, the searchers line. So if you have any um, load, add a line load, so you can add it. And strip, you can also add it. So from here, at which distance you have to give that value, you can also give that. I will select none. After that, uniformly lateral load, you have any lateral load, then you can select it here like that. Okay, so this is the way of adding lateral load. After that, extreme axial load, if you have value on extreme axial load, then you can also add it like here. So you can give it dead load, live load, eccentricity, anything here. And also if you want to uh, provide any seismic loading, so click here, has backfill seismic load. After that, KS and KV, we know that for our for our earthquake load, for soil properties, for backfill, we consider KS and KV and frictional angle, so you have to give here. I will not consider that. So it's done. After that, we have completed our load. Now we'll go for footing. So from here, what is the our footing says? So here you are seeing that every here the stability check, toy check, then heel check, stream check. Here we are seeing that stability check and stream check both are not okay. Okay, so we have to complete that. Okay, we have to do the bearing eccentricity, then stability, like that. We have to change that. We have to modify our retaining wall so that we get here the positive from of our work. So what is the here bural depth? What will be the depth? That depth, it's considered 4 feet. Okay, then river, here river properties, yield strength, it's 60 psi, 60,000 psi, and concrete Fi, it's 3,000 psi. Then unit weight of concrete materials, 150 pound per cubic feet. We know that it is it. And footing geometry, here you have to modify the footing geometry. It's is it record. So here its thickness is 12 inch, and then its hell length is 2 feet, and toy length is 2 feet. So if we increase that, it's if we consider it's 3 feet. Here just see that stability, here bearing eccentricity have been removed. And also if we increase toy length, then here also okay, but toy length is not affecting, so we'll give it 2. And if we give 3, just see here the variation 0.143, then 0.11. So also the sliding is uh, reducing by that. But if we give here 2, and also if we give a key here, okay, so if we give a key here, then it may reduce its sliding. So we'll see it later. After that, here we'll go here the hill reinforcement. Okay, so here footing with hill reinforcement, for has hill reinforcement. Then for hill reinforcement, it's footing with, then specified development length, then hook. You can do anything. So consider footing with. Then here bar size, consider we have considered number 5, but if we consider bar for 6, then if consider 5, then if we consider 4, it's also okay. For hill check, it's also okay. So we can provide bar 4. If we provide 3, then it's not okay. So we have to provide number 4 bar. Okay, then our hill check is okay. Now we have to go for here stream check. So we'll see it about a distance from here. What is it? But before that, from here it's toy reinforcement, the heel reinforcement, and for has the heel reinforcement, and for toy reinforcement, both are okay. So here number 5, if we use number 4, it's also okay. If we use number 3, then it's also okay. For toy, if we provide number 3 bar, it's also okay. Okay, so for toy it's number 3 bar, and for heel it's number 4 bar. And if we use number 3 bar, here it's reducing, but if we decrease its spacing, it's 10. If we provide it's 10, then what happened? It's also not working. If we provide it's 8 inch, then it's done. The main still is not okay, so we have to provide number 4 and we'll give it 12 inch as usual, so it's okay. After that, here it's done. After that, the toy clear cover here, okay, then heel bar cover, and after that transfer reinforcement. Okay, footing has transfer reinforcement. If footing has transfer reinforcement, what will be its bar? So its bar, if we consider 4, it's also okay. And spacing in, if we consider 3, it's not okay. Transfer main bar not okay, so we have to give her 4. So like that, it's being okay. So after that, transfer bar spacing, okay, 12. Now here it's showing the stability, I mean the sliding or anything, it's being failing, I mean our stability is failing for sliding. Here we are seeing that for sliding it's failing stability check. So if we provide a key, just see here they have, if we provide key, it will reduce the sliding. So key depth, if we consider 1 feet, and key width, if we consider 12 inch, just see it's also okay. So if we provide 12 inch into 12 inch a key under the footing, then it's working as a, I mean it's reducing the sliding. After that, now everything is okay except our stream check. So for that, we'll again go here stream, then uh, stream type. What is the stream type? Multi-section. If we use multi-section, as the multi-section stream, and if we select single section, that it's single section, then bar development at the top. If you use bar development at the top, you can use that by clicking here. So after that, has lateral support, if they have lateral support, okay. Support top offset, if you think that they have lateral support, you can give it here. Otherwise, remove that, you can remove that, okay. But I will consider the lateral support. Then the stream base is pinned stream, the stream base is pinned. If they have pinned, then you can use, or I will consider that is fixed. So after that, geometry, what is the top geometry here, 10 inch, and if we use tapered, then it's just being tapered, okay. You can reduce that. So after that, here reinforcement. So here we are saying that insufficient moment, okay, insufficient moment. So for that, we'll just, its height is 15 feet, it's very tall, its height is totally 15 feet, so we can reduce that height 4 feet, because here is our soil level, our materials level. So if you consider that 2 feet, then it's okay. And after that, now if we increase the bar here, reinforcement layout, if the single reinforcement or double reinforcement. So if we provide a two double reinforcement, just see that everything is okay, moment, shear, everything is okay when we are providing double. But if we provide single reinforcement, and also if we hook into hill, hook into toy, so we'll use hook into here, and lap with dual. So if you want to use lap, I mean lap length and dual bar size, as the lap length, you can provide the lap length and dual bar size. If you want to provide a dual bar here, so you can do it, okay. Then I'll not consider any dual bar, and after that, I will just, if I increase the bar size, just here, just see here, and if we reduce the value, it's 18, it's also increasing. So in insufficient main is still, so if we increase that 9, 11, but it's also insufficient, the main still is also insufficient. So for that, we have to use the two curtain, I mean a double reinforcement wall. So click here, it's double reinforcement, and we have to here base development is not okay, base development check is not okay. So uh, sorry, here we have provided that bar. So if we provide a number 4 bar, just see here everything is okay now. If we also provide number 3 bar, it's not okay, sorry. So for number 4 bar it's okay. And also if we increase its spacing 12, then what happen, it's not okay. So if we provide 10, then it's also not okay. So it's okay for 9 inch spacing. Just see that everything is okay here. So in this way we can design a retaining wall. Okay, I mean here the retaining wall design, we can do that like that. I mean the restraint wall. So uh, here, if you think that it was helpful for you, so don't forget to share our channel. And as you hear, that means you are a civil engineer, so I think that is helpful for you, because you have come till that point. So I think that is helpful for you. And if you think that also that is helpful for you, don't forget to subscribe to our channel, and also like, comment and video to our channel, because your own like and your own comment inspire us for the next work. So don't forget to support us and stay with us. So thank you very much. Stay well, stay connected till next video.